Hey guys, welcome back to another video. Today I am going to solve 169 problem, majority element, and we need to solve this problem with a linear time complexity and constant space complexity. Let's do it. Okay, let me explain this one. Here my solution, and this one our example from LeetCode. Here is okay. We need to create two additional variables. First one is just a counter, and second one is a leader, what we will return from our function. Okay, we have one for loop, just one standard for loop. We start from beginning of our nums array, and we have two checks here. First one, if our counter variable is equal 0, we need to change the leader. So by default we have a null value, and in first iteration of our for loop we will change the leader right away. Okay, second check is our counter. If our leader is equal current element in the nums array, we need to add 1 to our counter, or in another case we need to make -1 from our counter, and that's it. Okay, let's do it in this example. First iteration, and we begin from the 0 index of our nums array. First check, and here is leader is 2 now. Second check, counter. If leader is equal nums I, 2 is equal 2, right? So we add 1 to counter, and it is 1 now, right? We can move to the next iteration of our loop, to a second value. Here is first check is no need, and second one again, if leader is equal current element, 2 equal 2, so we should add to counter another 1, and it has a value of 2 now. Second iteration of our array, and here we have something interesting. It's another value with check. In current iteration, leader is not equal current value is not 2 is not equal 1, and we should make -1 from our counter, and counter is 1 now. Second iteration of our loop, and again it is not equal with our leader, and we should make -1 to our counter variable, so it's 0 now. Second iteration, we can go to the next value, and now we need to complete this check. So counter is equal 0 now, right? And this is why we need to change our leader to the current value. This is 1, so the leader variable is equal 1 now, right? Second check, again if current value equal leader, 1 equal 1, so we should add 1 to our counter. Alright, next one, next iteration, this is 2. And 2 is not equal 1. This is why we need to add -1 to our counter, and our counter has a 0 value again. Next iteration, this is 2. And our counter is 0, so we should change the leader value, and it has the value of 2 again, and that's it. Last check, counter 2 equal 2, so the counter is 1. That's it, and we need to back the leader value. This is 2, so we solved this problem, and that's it. Let's write our code. Here we can use a null value or a null one value, it doesn't matter really. We should return our leader first check. Second check for our counter. Short for. Alright, let's check. Looks good. We already solved this problem, and we have a great result here. Alright, let's think about complexity of this algorithm. First of all, it's space complexity. We have just 2 variables here, counter and leader, and they have a constant space complexity. This is why we have total constant space complexity. Now let's think about time complexity. Every time we need to check each of elements of our nums array. So this is a linear time complexity O(n), but we can add a small optimization to this solution. So what is it? If our counter already has a value more than nums length, right, like with we don't need to check left values in our nums array, and we should return leader right away. So in this case we have a time complexity. Only in the worst case we check each of element in our nums array. Okay, that's it, and see you in the next video. Bye.